In this video, we're going to talk about creating a model with the sprue in place. So milling the model ready for casting with the sprue intact. And basically what we have here is we have a model where the details all on the outer face of the ring to where the sprue, you'd want to sprue to the inside of the band so that it didn't take away from any of that detail. So to create the sprue, I'll just go ahead and delete this one. To create the sprue, basically all I did was create a curve that I knew extended into the ring. I've got grid snaps on. So make sure it fully penetrates the inside of the band and that comes down and maybe turn grid snaps back on and make sure it comes straight down to the construction plane. Okay, and then we're just going to pipe this. So in the solid menu, the button here on the first button, second row, is pipe. We'll go ahead and click on pipe, and it's going to ask us for a start radius. Remember, that is the radius, so whatever number we choose here is going to double. Or we could just toggle to the diameter function and start with, or work in diameter. Either way, whichever one you're more comfortable in. So the radius here, for the start radius, I wanted it to be about, let's say 2 millimeters, so we'll have a radius of 1. And the end radius, I want it to end about 3.2, so we're going to change this to 1.6, half of 3.2. And then press enter to end the command, and that's going to give us our first gate. Now we can take this and we can polar array our gate. In the transform menu, polar array, and you're going to want a polar array. Polar array is a viewport specific tool, so we need to make sure we're in the viewport. We want to array around a point in space. Select the object to array. That's going to be our gate. Press enter. The center of polar array is going to be F4. And I want 3 items, filling 360 degrees. And that's what this looks like. So that looks pretty good. I might want to pull it out of the ring a little bit, so I'll just back it down. And then last but not least, we want to add a support. And the support we could just use, let's use cylinder, and we'll start the cylinder at F4. And remember that our sprue at the widest point is 3.2 millimeters, so if we wanted to just extend that, we could go 3.2. And we'll make it about 4 millimeters tall. It's real important. Oh, I was working in diameter there. Let's do that again. Base of cylinder, F4. The radius, 1.6. It's real important for your support that you make it at least 2 millimeters tall. And we'll talk about that a little later on. So we're just extending that sprue out ever so slightly. Needs to be, again, at least 2 millimeters beyond the model. Okay, now that we've prepared our model for the mill builder, I'm going to go ahead and job bag and enter into the Revo mill builder. Place the model in the model window, and you'll notice that it picked up that it's a ring model. Well, the orientation of the model is important for this case because we're actually going to tell it it's a non-ring model to access some of the other strategies. So toggle on non-ring model, which is going to give us a different set of strategies to choose from. And you need to make sure the orientation of the model is a little different than you normally work. Typically, the through finger viewport your ring rail, you'd see your ring rail straight through your ring rail and the through finger viewport. Well, I've rotated the model 90 degrees in the side viewport to make sure it's up and down and that we're seeing the ring rail in the looking down viewport. And there's the ring rail there, so you can see it straight down here. We're going to be choosing the support and inputting it in the support window, and choosing the 3-jaw chuck 1 millimeter at a time. Click Next. The software is suggesting that we use a 26 millimeter round solid tube. We have that, so we'll go ahead and click Next. And we're going to be choosing the 8 sides for this design. Clearly, we're going to need more than 4 to complete all of the detail on this piece. Click Next. On this page, you would choose the distance between toolpath that you would like to work in and click Next. Okay. For the part 1, the flat-on 3-jaw chuck, double click that to expand your options. We're going to put in a border, and we're going to use a manual border, and we're going to use our ring rail as our border curve. Let's go ahead and look at the cut depth. You can see it's not coming down far enough to fully clean up the inside of the sprue. So click Go and move that down. Press Enter to end the command. And then let's just go ahead and make our paths to see what that does. Okay, let's take a look at our tool paths. And you can see the first path, there's a little bit of a roughing pass that happens initially. It goes down and it mills part way down, and then it mills the full way down after it's roughed out the initial wax. And if you ever want to see, remember in the video, or earlier in the video series, we talked about changing the cutter definition to extend the pass depth. And if you're unclear on the technique here, you can refer back to the video on milling a head in the center of a ring rail. But let's go ahead and look at the cut depth again. And you can see if we went the full distance of that pass, you're going to bury the cutter. So it's really not a good idea to go anywhere beyond 14 millimeters on that cutter, and we're just delving 14 millimeters deep. So roughing pass is probably a good idea there, so I'm not going to edit the cutter in any way. And then the last 8 passes, mill the project 1 millimeter at a time. And see, these have roughing passes as well. But it mills 1 millimeter at a time, rotates the 45 degrees, mills from the other side, so that as it's milling down, it's keeping the rigidity. Okay, so this is completely rigid until it gets down to about here, and then it's starting to become more flexible, but it's milling 1 millimeter at a time. So if there's so that you can avoid any chatter that may occur if you were to try to mill this all in one pass, like on a rotary axis. The other thing to keep in mind is that if you look, that support is actually, it's not milling through the support. So everything looks good here on this pass. This roughing pass, we could look at seeing how deep we'd get if we were to change the cutter. So let's just peek at what it would do if we went the 14 millimeter depth and set that cutter and make our paths and take a look and see if it avoids that roughing, or if it eliminates that roughing pass. So let's take a look at our paths. Actually, in particular, that first path. And you can see that it added a roughing pass in anyway. So even changing to the greatest depth that we can delve into the wax, the 14 millimeter, did not affect the time in a positive way. It still inserted a roughing pass. So I'm going to go ahead and change that back to our standard 10-degree cutter and make paths again. There's no way to avoid that extra time, and so it's better just to be safe and let it do its automated roughing passes 10 millimeters into the wax. And if you're unclear on any of these techniques, again, refer to the video on milling ahead in the inside of a ring rail. So again, we'll just peek through the paths to make sure everything looks right. The first one is the top down cut. That looks great. The next subpart, again, verifying that it's seeing that support. This is exactly what I'm expecting to see. We've got the cut new only. So it's only milling the parts that haven't been reached on other passes, because in the more options, the cut new only is in effect on the last 4 cuts. And this looks great. So just as a side note, I think it's important to understand the way that borders are calculated in the software. Remember earlier in the demonstration I talked about how it's important that the support is at least 2 millimeters offset from the model. Well, if you remember, any border is automated at 2 millimeters. Okay, so the software automates a 2 millimeter outside border to the project. So in the event, I'm just going to back up in the software here. In the event the support that you created does not extend more than 2 millimeters off of the actual geometry, it's going to, the support isn't going to be long enough to overlap the border. It's important that every single support is at least 2 millimeters greater than the geometry, so that the border that's created intersects with the support. For example, if we go 2 millimeters beyond the geometry in any given portion, or at any given point around the ring's geometry. Okay. If this was actually 2 millimeters offset, you'd see why it's important that that support extend 2 millimeters beyond. If it doesn't, say the support is tucked up into the geometry, the support may be 4 millimeters, but it's not 4 millimeters offset from the project. When the custom border is automated, it's no longer going to intersect with that support. So you're going to end up having this mill completely off and fall off the mill in the middle of the milling process. So for example purposes, we'll just go ahead and take it in through the software so that you can see exactly what I'm talking about in the toolpath generation. And we'll make paths. Okay, let's go ahead and take a look at some of these cuts. Okay, See how the toolpath, the support was not extended far enough, and the custom border that it automates in the software is 2 millimeters beyond the geometry. So it's actually cutting the entire model off. That support is doing us, it's not acting as a support. So you just need to make sure that supports are always at least 2 millimeters beyond the geometry, so that when the custom border that's automated in the software mills out, that it doesn't mill away, cut through the support. Along this same concept, let's look at another project real quick that I think will just drive this concept home. Moving too quick. Okay, this is an older model, but we'll just get rid of the gem. Get rid of some of this stuff. And if we wanted to mill, say, this top portion, same strategy we just used for milling the sprue, except there's no geometry down here that we're trying to mill. You don't see the sprue down below the inside of the bezel. Okay, this is just empty space. So let's throw the model in the model window. It's a non-ring model. We'll create a support, or a couple of supports. And we'll just polar array these. Okay. Throw the supports in the support window, and we're going to choose the 1 millimeter at a time option so that it keeps the rigidity. It mills 1 millimeter, rotates 90 degrees, mills the other side, rotates 90 degrees, mills the other side, or 45 degrees if you've got a lot of details out at this corner. So since we do have a lot of details, instead of rotating 90, we're gonna choose the 8 options and rotate 45 degrees in between each step. And I'm going to go ahead and make paths here. Okay, let's take a look at these paths. In particular, this flat on three jaw chuck horizontal. And what you'll notice is that it does not mill this center section. So the center section is going to be a big chunk of wax up here. And if you take a look at the picture in the lower right hand corner, you can see the evidence of what happened there, or what it looks like in a milled piece of wax. The reason for that is because of those automated borders. It saw the geometry, it offset the geometry by 2 millimeters on each side, and it mills only in between there. So it doesn't want to waste your time milling stuff where there's no geometry. Okay, so in this case, well, maybe I want it to mill this empty space. If I want it to remove that wax, there's an option within the advanced or the more options section called fill holes. And any hole in anywhere where it would automate the borders and put a hole in the geometry, it's going to fill. So this is in the up and down path. So we're going to choose the up and down option and go ahead and hit make paths again and take a look at the difference in what that looks like. So now if we examine the toolpath after changing the fill hole option, you can see that it filled the the holes with toolpath. So it didn't see anything that it saw as a void or an empty space it filled up, and it actually mills in that area now. So that's what we want to see. So that's a little bit more about the way borders work and the fill holes option under more options. The reason why we didn't have to use the fill holes when creating the sprue was it saw the sprue geometry down here as part of the model, so it knew it needed to mill that geometry, so it didn't make empty cavities in there. So that will conclude the creating a sprue in the model video and understanding a little more about fill holes and the way borders or automatic borders work.